Okay. First, if we discuss about the structure of these lenses, so concave lenses are like this. They are thin at edges and right. And when we draw convex lenses are like this. So these lenses are thick at the center and thin at the edges, right? So this is the
Yes.
basic difference between these lenses. And further, if we discuss about their properties of rays when light rays passes through these lenses, so concave lenses will diverge light rays, right? Diverge light rays. So that's why these type of lenses are known as diverging lens. And in convex lens, these are known as converging lenses because these lenses normally focus light rays on a single point or on a focus point. So that's why these lenses are known as converging lens because they normally converge light rays. So this is an other difference between these lenses. And if we discuss about the nature of image, so what will be the nature of image in concave? If we discuss about the image nature, so if we write the nature of image for concave lens, so what will be the nature of image when light rays passes through concave lenses? Is it real or virtual?
Would it be real?
Okay, so let's discuss the difference between real and virtual image first. Then again we come to this discussion that either is it real or virtual. Let's suppose two parallel light rays are passing through the concave lens. So they normally diverge light away from the normal like this, right? So these are diverging rays because concave can easily divert the light rays which are passing straight through it. So there will be no image form on the screen. If there is a screen placed there, this is our screen. And let's suppose there is an object placed here at this point. So if you placed object on the left side of the concave lens and you want to observe the picture of that object on the screen, so there will be no image on the screen. Why? Because these rays are diverging from each other, they are moving away from each other. So when light rays or any rays passing through the lens are moving away from each other, they don't intersect each other. It means that there will be no image on the screen, right? Let's suppose there is a candle placed at the point of object, and in between screen and the object there is a concave lens which is diverging, and next to it there is a screen on which we want to observe the image of the candle on the screen, right? So in practical experiment you can't observe the image you can get the image of that object on the screen, because the light rays are diverging, they are not intersecting, they are not combining at one point, so there will be no image formed on the screen, right? So when there is no image on the screen, so the image is known as virtual, right? Okay.
Yes.
So this means that the first nature of image is virtual. Virtual means that you have to observe the image of object from this point. This is our eye level. So when you saw object or when you observe the object through the lens, so you can clearly see the image or the picture of the object through the lens. So when you are observing the object through the lens, that image is known as virtual, because the size of object is something different from the image that we are observing from the lens, right? And when the image of the object through the lens will form on the screen, so then we call that image as a real image, because image is formed completely formed on the screen, or you can say on the other side of the lens. So when you can observe the image of object on the other side of the lens on screen, so the image will be real. But when you can't get the image of the object on the screen, then you say the image is virtual, right? And if we talk about the orientation of the image, let's suppose there is a arrow. So the image of that object which is in arrow form, so you can clearly observe the object image in same orientation which object is placed. So that's why we use term erect for it, which means of same orientation, right? The image will be of same orientation. That's why we call the image as an erect image, and virtual because we can't get the image of an object on the screen, right? And if we discuss about the converging lens, which is convex, so convex works completely different from the concave lens, right? Because the convex lens is a converging lens. So when we pass light rays through the convex lens, this is a convex lens, and there are objects is placed at some distance, and light rays are passing through it. Let's suppose if we consider only two light rays which are passing through the lens, so they converge light rays to a single point. So when light rays intersect each other, it clearly means that you can get image on the screen, right? So you can completely get
Yeah.
the image of an object on the screen here. So the image will be real. And if we discuss about the orientation of an object, so what will be the orientation of the object? Either is it erect or in inverted form. You can clearly see that this is the head of an object and this is the tail of an object. So the light rays which is passing from the head of an object are moving downward, and the light rays coming from the bottom of the object are moving towards upward direction, right? Like this. So the formation of an image will be like this, upside down image, right? So image will be known as an inverted image. Okay.
Okay.
So this is the basic difference between the image formation and the type of, or you can say that the nature of image in concave and convex lens. There is a property of a convex lens that it can also form virtual image in some cases. When we discuss about the image formation at different point, so we can observe there that convex lens will also form a virtual image, right? So it can also form virtual image and real image, but in concave, concave will always form virtual image, right? Because it always diverges the light rays, so light will not intersect each other. So that's why we don't get the image of an object on the screen, right? Okay, now if we discuss about some terms related to the lenses, so let's suppose there is a convex lens and there is a reference line for us which is passing. So this reference line is known as principal axis, right? This is known as principal axis, right? And this center of the lens is known as the optical center. So the center of the lens is known as optical center and the reference line passing through the optical center is known as principal axis. And if we place an object over here, so there are two types of waves orientation which is passing through the convex lens. One possibility is that ray is passing parallel to the principal axis, right? And the other possibility is that rays are moving from the optical center of the lens, like this, right? So there are two types of rays, or you can say that the two types of possible orientation for rays that are passing through the lens. First one is parallel to the principal axis. We can write it as number one, parallel to principal axis, and the second one is a light ray which is passing through the optical center or through the center of a lens. So after these two rays with different orientation are passing through the convex lens, so the final image or the final ray diagram for these rays will be like this, that the line which is passing parallel to the principal axis will bend towards our principal axis line like this, and the second ray which is passing through the optical center will move straight without any deviation or any conversion or any divergence, right? So you can get the image of an object somewhere at this point, and the orientation of that image will be like this, right? Normally we draw ray diagram to identify or to discuss the nature of the image at different distances of an object. So that's why we draw a ray diagram, so it becomes very easy for us to identify the nature of the image, right? So these are two types of rays orientation. You need to always remember these two principles. These are basic principles for the rays orientation. So these are two types of rays orientation or the principle for their rays orientation. And at this point, after passing through the lens, this point is known as the focus point, right? Because when different light rays which are parallel to the principal axis, when they pass through the lens, they always converge at a same point, right? Which is known as the focus point, or you can say that point can be known as principal focus. You can either use the term of focus point, or you can also use term of principal focus, right? And if we measure this length, the distance from the lens to the principal focus or the focus point, this distance will be known as focal length, right?
Yeah.
So this length will give you the focal length of a specific lens. Depends upon the orientation of lens, thickness of lens, and the size of the lens. Small lenses have low focal length or less focal length, short focal length, and lenses with greater size and greater density have greater focal length. And you can draw on both side focal length because light can pass at both side from this lens because lens is completely transparent. So either you can pass ray from the right hand side or either you can pass ray from the left hand side, right? So these are some basic terms or key terms in the case of this orientation. One is principal axis, other one is optical center, and these principal focus and the focal length, right? Any confusion?
No.
Okay. And if we double the distance or if we double the length of focal length, so you will get the value of 2f, which means that this length is twice of the length of focal, right? Yeah, principal focus. So this will be double in the length according to the focal length of the lens, right? Okay, so this is basic formation for convex lens, and if you want to draw the image formation in concave lens and you have to find out the focal length for concave, so we can simply draw imaginary lines behind the mirror like this. So when these light rays are intersecting each other, these are imaginary lines in practical example this can't be happen. So we just draw these lines to find out the focal length of the concave lens, right? So that's why we get
Yeah.
erect or same orientation image in concave lens and inverted in the case of convex, because from ray diagram it is clear that the image of the object will be inverted upside down. So this is the basic concept of the image formation in concave and convex. And if we discuss about the image formation through convex lens at different point, so how the image will be formed at different places. Let's suppose if we discuss some points regarding to the different positions of object in lens. So if we first discuss about, this is basically image formation in convex lens. And in our first case, let's suppose object is placed at 2f, right? Twice of focal length. So the image formation we get in this case like this, there is a convex lens. Then we draw a principal axis there. And there is an object placed over here. And this distance will be equal to 2f. So this will becomes our f. This is also f. This is twice of focal length is equals to 2f, right? This is our first case when image is placed at 2f, right? So light rays, as we earlier discussed, the basic principle for the orientation of light rays are passing from this point, which is parallel to the axis, and the other one is passing through the center of the lens. So the image of an object will be formed at 2f. Image will be formed somewhere at 2f, right? So when object is placed at 2f, the image of an object will also form at the same distance, right? It means that if you want a clear image of that object, so you need to fix your screen at the distance of 2f, right? So you get the image of that object on the screen at a distance of
Yes.
2f. So this is our first condition. And if we discuss about the nature of the image in this situation, so what will be the nature of this image? Image is real. First point, the image is real in nature. And second one, and what about the second point for the nature of image? Inverted. And what will be the third point? If we discuss about the size of an image, is image highly magnified, small in size, or something else? So the image of the size will be same as an object, right?
Okay.
Okay, so this is our first case of image formation. Image will be real, inverted, same in size. And let's suppose if we place an object behind 2f, let's suppose object is placed beyond 2f. So now image is going to be placed beyond 2f. This is our principal focus. And 2f will be somewhere at this point. This will be our f, f to f, and object is going to be placed beyond 2f like this. So how image is going to be formed in this condition? Same orientation of ray. One is parallel to the principal axis and second one is passing through the optical center or from the middle of the optical center like this. So we will get the image of this object at this point, right? So the image of an object will be formed at this point. And one more point you can write here, that image will be formed at 2f. Now if you want to write the nature of an image for this situation, so image will be real and inverted, or number 3, between, image will form between f and 2f, right? And what will be the size of the image? Is it small in size or magnify? It will be small in size, because when some object is placed at a very far distance from the lens, so image of that object will be very small in size, because object is placed at a very long distance from the lens. There is a very simple trick to remember these image formation. Whenever you shift object away from the lens, right? So object is shifting towards left, right? According to our first case. So our image will also shift towards left. Like in first case, image will form at 2f, but when we shift our object towards left, so our image will also shift towards left hand side, right? So image will be in between f and 2f, right? And if you shift your object towards right hand side, so the image of an object will also shift towards the right hand side of the lens, right?
Yeah.
Let's suppose in third case, if we placed object in between f and 2f, in third case, object is going to be placed object is between object is placed between F and 2F. So the image of that object optical center, principal axis, and object is going to be placed in between F and 2F. So this is our 2F and this is our F, equal distance from lens on the other side, and object is going to be placed in between F and 2F. So the image formation for this situation, so image is passing through this optical center and one is parallel to the surface. So the image will form beyond 2F like this, right? So this will be the final image of an object, which is again inverted in form, but there are some different properties here. We can say at this point, image will be real. Number two, that image will form beyond 2F, right? And inverted in form. And what about the size of an object? Either is magnified or small in size, because now object is placed very close to the lens, just like when we use magnifying glass while reading small numbers on some microprocessors, or when you try to read some small letters from some book or some text you want to read. So image will be very highly magnified, right?
Yes.
If you want to calculate the magnification or exact magnification of any lens, magnification, you can simply calculate the magnification by using formula. Magnification is the size of an image divided by size of an object. So this ratio will gives you the exact magnification value by dividing these two different sizes, right? So you will get the exact value of magnification passing through that lens, right?